Hello everybody and welcome back to another episode of Coding with Kenny G. Now we're at episode 15 and we are starting to move our actors on the board. But there was a little issue last episode because there were some null refs when we were trying to move a guy. That's because we haven't updated the actual game board itself. Like when this guy moves from this position to this position, the game still believes that this tile is occupied by this guy because we haven't updated it yet. So we are going to implement a few things to actually keep track of the current state of the board and simplify some interactions as well. So let's go into script. So we're in actor selector script, and right now I'm teleporting this guy. I'm just putting his position into a new position. But first of all, it's much cooler to move an actor over time than just shifting his position in a teleport fashion. We don't need to be Star Trek here. So the thing is that we're going to create some functions inside actor class, which we are going to talk to, and some events. So let's go to the actor script, and for a public function, an outside script is going to allow this script. Is going to allow another script to ask it to move this actor to a world position. So we're going to create that function. It's called public void move to world position, and then we're just going to send in maybe move to tile in this case. It's a little bit more local for our game, but that's fine, because we need to send in the tile, which is the from tile, and then tile, which is the to tile, the guy that we're moving to. And here's the thing. An actor is just gonna tell the world around it through an event that it has started moving, and also that it has ended moving. We're going to do this through events, and in this game, we are only moving one actor at a time. So we can have a static event. This simplifies a lot of interactions, because then I can just I don't need to know the instance of the actor that is moving. I just need to listen to some actor moving through a static event, which is quite helpful. So we're going to create two events in the actor class, which is the public static event system.action again, with a payload of actually actor, which is we're going to send in the source, which is this guy, the instance of the actor that is actually moving. So actor, and then another payload, which is tile, and another payload, which is tile. This is the one little wonky thing. I wish that we could name these variables in C#. It might be a feature that is coming, but we're not allowed. So we as programmers, we need to know that the payload at position 2 here is the from tile, and this is the to tile. We need to know this ourselves, but I'm gonna help us out with a comment. So on actor start move is the name of this event. Then we can create a summary with the 3 forward slashes, and then payload : 0 equals the actor that is moving. 1 equals from tile, 2 equals to tile. So this refers to each of these payloads. We can just copy this entire thing with the summary, and this one is called on actor end move. Okay, so we're gonna move this guy inside a coroutine. If you aren't familiar, coroutines are super helpful little functions that work as sort of like an update loop that you can start at and stop again. Like the void update would just always run, but a coroutine runs until it is finished, which is quite helpful. And we're gonna lerp linear interpolation. We're gonna lerp the position of this actor over time. So first of all, we can add some public variables to our actor here, which is its move speed. Public float move speed, and let's say that this is yeah, let's just start at 1f. I don't know what the value will be. We can header this with tweakables, and for this guy we can tooltip it how fast the actor moves from position A to position B, and I think this should be in seconds. Yeah, because we're lerping, so it should move to position A to position B in the same amount of time each time. So if it has a long distance, it will look like it's running, and if it's a shorter distance, it will move actually a little bit slower but reach the position at the same time. Okay, so move speed, that's cool. And we're gonna create a coroutine in a private functions. So in order to create a coroutine, you need to write private, and it needs to return IEnumerator. This is the thing that lets us be a coroutine, and the name of this function is move to pose world position, and then we're gonna take in float t, which is the time, and the yeah tile to tile. Yeah, we also need to send in from tile as well. Tile from tile. Separate by commas. What did I do? Oh, there we go. Okay, and it's gonna be red because we're not yielding yet. We need to yield inside an IEnumerator, but I'm gonna show you. So when we start moving, we can fire off the onActor start move event. We can just do this inside a coroutine. In Unity, you need to start the coroutine using a special function, so it's called start coroutine, and then move to world position, and the t is our move speed. From tile, which is a parameter, and to tile, which is a parameter. One little thing, if you're unfamiliar with coroutines, this is a typical mistake. You can call the position, move to world position, and send in the parameters, move speed, from tile, and then to tile. And it seems like this function is working, but it's not. At least not in the coroutine way. The coroutine needs to run many times, normally. We're gonna move this position of this object in steps, right? Which is exactly like in an update loop. But many people, and it's easy to make the mistake of forgetting to call start coroutine, because then we are starting this function the way it's supposed to run. But you won't get an error if you write this, which can be annoying sometimes, because if you're blind, right, and you just can't see what you're doing wrong, this is just one of those typical things. You've got to write a start coroutine. Okay, so now this guy is running. And then we're gonna go into this coroutine function, and we're gonna write float cur lerp time equals 0f. And then we're gonna write while cur lerp time is less than t. Then we're gonna start moving the position. First of all, before we do any of this, we can actually start, we can fire off this event on actor start move. So we're just gonna invoke it on actor start move, question mark point invoke, and then we need to send in these parameters. For the source, we can write this, because that is referring to this instance of this actor script. And we write from tile, which is a parameter, and to tile. All right, and then inside here, we are going to move this position of this object over time. So transform dot position equals vector3 dot lerp from current transform dot position to tile, or actually okay, we haven't added this yet, but let's create a getter or a helper function inside the tile class. So we can just write public vector3 and get tile world position, and this will return new vector3, where we send we say my board array index dot, or actually we can say return transform dot position. Yeah, it's a nice little quick helper to be a little bit clear when we are calling the code, what we're actually trying to do here. So we're lerping the actor's transform position between its current position each frame to to tile dot get world position, and then the t is the cur lerp time, and I think we divide this and I multiply by time.delta time, don't we? We need to remember to yeah, we don't multiply by time.delta time here. Remove that. We say cur lerp time plus equals time.delta time. And then if cur lerp time is greater than t, cur lerp time equals t. So what's happening here is that we are moving this transform a little bit, frame by frame, and after that, in order for this to function as a sort of update loop, you need to yield return null within the while loop, and then it will resume control to the main thread and return next frame to this position and start this while loop again. So this works as a little mini update loop that you can start and stop, which is super helpful. After this statement has become true, you need to do a little thing where you actually set the position to the exact position that you want. Which is because of precision. This lerp might not put the transform at the exact position that we want. So after we finish this while loop, we set the transform dot position is equal to to tile dot get tile world position. Cool. And then we invoke the on actor end move. On actor end move. Invoke, and yet again this from tile and then to tile. Cool. Let's think here if I have done everything I think I need to do. First of all, we can check if this function works, as in move this guy frame by frame instead of teleport. So we do we go to actor selector and we write actor to move dot move to tile, and the from tile is the selected tile and the to tile is the T, the one that we got in. This is the target. Alright, let's see if this works in Unity. So return to Unity, press play, and then select this guy and move here. Shoop! And he moved quite fast. Now there was just the issue that this guy, in terms of our game state, he's still on this tile and not that tile, even though the object itself has moved. So we need to update that, and that is why I added these events, because we are now going to update the position on the board based on, we can decide if we want to update the position when it ends its move, rather update it the board in which tiles are occupied. Either you can do it on the actor start move. This can be good for some reasons, that we can kind of, if we update the board on actor start move, Everything else is in the movement of the object itself. It's just merely a visual thing, actually. But in our game, I think that we are going to update the board on actor end move, because then at that point in time, that is where we are going to check for a lot of game mechanics in this game. So when you end a move, did you capture an opposing actor piece? Did you win the game? There's a lot of stuff that can end or happen at the end of a move. But okay, and at this point in time, it could make sense to create something called a game controller. A game controller is usually present in most games. Some also call these managers. I'm allergic to the word manager for some reason, so I call everything controllers. Personal taste. Okay, so scripts. Let's create a game controller. Game controller. And this guy can be present in the scene as an object, actually, even though it's just an empty. And we call this game controller. We slap on the component game controller and we open it up in Visual Studio. And this guy is definitely a singleton. We're just gonna do that straight away. So we're gonna create a singleton pattern, singleton. Sometimes I slur these words, sorry about that. Public static game controller instance. So we're gonna set up the singleton pattern, void awake, if instance equals null, then instance equals this. If instance is not equal to this, then destroy game object. Cool. There we go. And I'm thinking that since the game controller is going to check the game mechanics at the end of a move, it's gonna. The game controller is the one that kind of handles the overarching structure of the game. For example, the game controller can tell the turn controller, a state machine, that hey, now the attackers have attacker faction has finished their move. Now we change the turn to defender, stuff like that. So it's like a boss. We could also let the board itself update itself. But since game controller is gonna do things in sequence, like after an actor has moved to a position, then do this, then do this, then do this, then do this. It's kind of important that these guys or functions happen in sequence. So I think that we're going to allow our game controller to update the board. So our game controller is going to listen to the event of actor start move and actor end move. So we're going to write void on enable and void on disable in our mono behavior callbacks. Event handler, private, void on actor start move. This one takes in an actor A, a tile from tile, and a tile to tile. We can just copy this function on actor end move, and it's the exact same thing, and then we have to listen to this. So I created this as a static event, So we're going to listen to the actor class itself on actor start move plus equals on actor start move. Boom. Desubscribe always like so, and actor dot on actor end move plus equals on actor end move on actor end move minus equals on actor end move. Good. So we have subscribed and desubscribed to these important events. And here on actor end move, let's update the board with the new state of the board. For now, capture or other mechanics haven't happened yet. We do this later. Okay, so let's update the board. And the way that we do that is to say that first we're gonna call board. We can actually have a local ref here now. Var board equals board in capital letters, board.instance.get board, and we say board at position from tile.x and from tile.y dot set occupying actor to null. So that tile is now empty in terms of our game state. What did I do wrong here? Sorry. From tile dot get tile index dot x and from tile dot get tile index dot y. Cool. And then we're gonna update the new position. So board at position from to tile dot get tile index dot x and to tile dot get tile index dot y dot set occupying actor to A. And honestly, that should be it. And also, since we are now moving an actor, we shouldn't really be allowed to click on anything or do this camera controller tile selection inputs. So that's why it can make sense to ask our camera controller to disallow input, set is tile selection enabled to false while something, or rather an actor, is moving, and once it's at the position, for now we can allow input again. So camera controller instance.set is tile selection enabled to true. Okay, let's just see if this works. So I'm gonna press play and I'm gonna try to move this guy to a position, and then I'm gonna try to move that guy again. If I'm able to click on him at this position again, it's working. Our board is now updating the position, or rather it's updating its state after an actor has ended its move. And I can try to move this guy and click here, and I couldn't click this guy while this guy was moving, which is good. It helps us clean this interaction up quite a bit. And now we're soon ready to implement a turn-based game. So we actually got quite a bit of this machine running already. We should have some sort of deselect. You can click outside, but maybe we should allow to deselect this guy if I click on him again. Yeah, I think we're really starting to get somewhere here. So I hope that you learned something from all of this so far, and I'll see you in the next episode.